Okay, hello. My name is Alexander, as you heard, and I'm having this talk from my home in Gothenburg, Sweden. Today's keynote is the evolution of modern Python. So, you heard a little bit about me, but just shortly, I'm the founder of Hultner Technologies. You can find me on Twitter. I'm at @Hultner. That's where I'm most active. You can also contact me via email if you want to get in touch with me at contact@hultner.se. My website is hultner.se, and all the slides from this keynote and most of the talks I've had previously as well is at slides.com/Hultner. You can also find me on LinkedIn on linkedin.com/in/Hultner. And you will see throughout my keynote that some of the links in my slides are blue like this. All those links are clickable. So if you want to read more about any of the resources I provide in my slides, you can go here afterwards or during the keynote and read more. So let's get started then. So short introduction then. The focus with this keynote will be the modern Python and what's been happening with modern Python in later years. So I will not focus on the transition from Python 2 to Python 3. As you all know, last year we left Python 2 officially behind with the end of life. So we can finally look forward. Based on that, there is some really great features I want to talk about, and it's hard to believe it, but it's been 13 years already since the early versions of Python 2 surfaced, and what's been happening the past few years is actually very interesting, and now we all can really feel that we can take full advantage of it with the Python 2 finally out of the mind of us, and with just a year since it was officially declared end of life. So the first release of Python 3 was in 2008, and Python 2.7 was released in 2009. So it's been quite some time. During this talk, I will talk about my journey with Python. So I will be starting somewhere around Python 3.4. So without any more delays, I will go into that. So at the time of 2015, I was working at a company called Heliospectra. So Heliospectra is a Swedish company which does basically smart greenhouse systems and does a lot of things with LEDs. So we produce the LED grow lights, but also smart control systems for industrial greenhouses. And these days, these industrial greenhouses are more like an advanced factory with robots and everything than what you would think of as a traditional greenhouse. But we also worked with other very exciting companies like or not the company, it's more like a research collaboration with the ESA, the European Space Agency. And they have a project called Eden ISS. For those who never heard about it, probably most of you, the point of that project is to be able to create a way to grow herbs and food and similar things on the ISS, International Space Station. So basically The Martian, if any of you have seen that movie. The idea is to be able to grow things in space so we don't have to send up food all the time. This was something we also helped with. So anyway, at the time Python 3.4 was out. It was the current version, and we were about to replace our old control software, which was a native desktop application. And it was more aimed towards smaller installations. So it was used by universities, by scientists, by researchers. And instead of having a server-based approach where you have a server or a control system in the greenhouse that all the way control it and got its eyes on everything all the time. They more worked with just having it on their desktop. So we wanted to more tightly integrate everything and make it work more in an industrial scale. So before going further, I just wanted to show this is actually from the Eden ISS project. It's in trial right now. So they've been putting these containers on the South Pole. And that's basically the place on Earth where you most closely can simulate the kind of situation you would have when you try to farm in space, basically being disconnected from everything else and with snow all the way around. So in this installation, they are actually trialing doing some of these. And you can see all the light fixtures here are from Heliospectra. So all these were from the company I worked at, and we developed these custom water cooling loops to be used basically to be able to handle the constraints of such an installation. But let's go ahead and talk about the control system. So we were about to develop the next generation of control system. We had our old desktop software, and it was written in Python 2.7. So we were thinking that maybe the best thing is to keep using Python 2 because we have libraries and we have code already working. And I took a few days, maybe a week, to build a modest proof of concept where I basically ripped out the core of our existing application. I removed all the desktop UI parts, and then I threw a tight Flask JSON API on top of that. I added a small JavaScript-based SPA, and all of this was running on a first-generation Raspberry Pi at the time. So not a very powerful computer, but it did run it, and I were for the first time able to control all this cool hardware with the flick of my finger on an iPhone screen. So that feeling was quite marvelous. So we decided to go forward and actually build out this new control system. And we were thinking about using different languages, trying something new, but we decided to use Python because we already have engineers that know Python. We have experience with Python, and we actually like Python. But I was actually looking more towards Python 3. At that time, there still was an earlier end of life date, which was closing in. So I also thought that going forward, we don't want to be stuck in a Python 2 code base, especially not when we want to rebuild the core architecture anyway. So I went to the drawing board and started to think about how we could go about doing this while mitigating the risks with actually moving to a newer version. So while heavily leaning to Python 3 and thinking that this was the future, the choice wasn't obvious anyway, because we still had old code, had old libraries, and we weren't sure if they would work. So my suggestion was to utilize a modular architecture where each component had its own process, and we used inter-process communication. So we communicated with each component over a Unix socket and using APIs between them. So back then it was Python 3.4 initially. Python 3.5 was released during the initial development, and we upgraded just a few months after it was released. So that was quite nice, and we instantly started to utilize the new splat operators, for instance. And it actually turned out that we never needed Python 2. We could do everything we wanted to do in Python 3. It was more the fear of not being able to do it that was holding us back. than actually doing it. So by having the modular architecture, we actually could go back if we needed to, but we didn't need to. So at this point, I was fully convinced that Python 3 is the way to go. It's great and it's the way forward. So with that said, I'm gonna go a little bit into the actual versions during this time. So it was Python 3.4 first. It was released in March of 2014. And some of the significant features are the enum module, which most of us probably take for granted today, but it wasn't in the initial Python 3 versions. So in Python 3.4, we got enums. But we also got the async IO module, so a new framework for async IO, and that has really taken off the last couple of years. But it was in 3.4 the first building blocks that could kind of power this new async world were actually added to Python. And we also got pathlib, which gave us a much cleaner way to work with file system. And yeah, I think that's also one of the really great features of Python 3 and modern Python. And of course, there's many more features, and you can read more about it in the release notes. And as I said before, all the links are clickable. So in case you want to go back and read more about any of these features, you can go to the slides and click the links. So let's go ahead with Python 3.5. As I mentioned briefly, we got the splat operators for unpacking. So basically being able to unpack lists using the star, or dicts using the double star or double splat. And of course, other iterators and mapping types as well. We also got coroutines with the async and await syntax. So we had the async IO in the previous version, and now we got the async await syntax, basically the fundamentals to use modern async. And we got PEP 484, which was the typing module and the new standard for type annotations. So all these things were actually released back in September of 2015. But it feels like this past 2 years, these features have really taken off. We got also some improved zip application support. So basically that you can execute a zip containing a Python module and with a main __main__.py file, which will be executed automatically. And this is utilized in some formats. I think it's used like by Shiv and similar things. And of course, many more features in the release notes. These are just the ones I've found significant and that's been affecting me a lot. So next period of time, 2017 to 18, time to level up. So I was prototyping a new application where I started to utilize many of the new features that was added to both Python 3.6 and previous versions. So around this time, Python 3.6 was released, and I immediately fell in love with the new F strings. Modern Python was only getting better. Was not only getting better, but also getting more friendly to use. So armed with this information, I had seen that Eric Schmidt was working on something rather exciting for Python 3.7, namely data classes. So you probably know about data classes now, but back then it was very exciting. And they combined the new type annotations with much more helpful and better class syntax with much less boilerplate code. So Python was yet again improving features and getting more approachable at the same time. So armed with an early reference implementation of Python 3.6, we started using them in our application stack. And this was only about half a year before the release, but it was still before the Python 3.7 release. So we were using the backport for data classes in Python 3.6. And I were quite excited about data classes and the built-in simple, and I built a simple runtime type checker and JSON parsing and formatting utilities for data classes. This was basically as a cool weekend project just to prove that it was possible. And I was with very little effort able to do this because I could access the types via the annotations __ annotations __ property, and that made it even more straightforward than I had imagined. So I wanted to share this newly gained knowledge with the world, which led me to present a couple of talks about data classes. First at the GovPy conference a couple of months before the Python 3.7 release. So that's a local user group we have in Gothenburg. But later also at the PyCon Sweden conference in 2018. And as for the, I forgot to go ahead and put these up anyway. So as for the runtime type checker and JSON utilities for data classes, I never released those publicly. And when I were thinking about it later, something named Pydantic came around with very similar goals and did it better than I did and had put more effort into it, which I do have a talk about on my YouTube channel. So if you're interested in that, you can actually just search on YouTube and find that. So let's go into the features of Python 3.6 then. So most famously, Python 3.6 gave us f-strings, but it also gave us the fundamentals that enable data classes. As a side effect of the performance optimizations in dictionaries, they became ordered in the reference implementation CPython. So a de facto standard in Python 3.6, but this was later formalized in Python 3.7. So Python 3.6 was released on December 23rd of 2016. And as I said, the probably most significant feature is f-strings. And here's a small example of how that works that I wrote for my PyCon Sweden talk 2 months back. And another one was preserving keyword word argument order and asynchronous comprehensions, but of course also the order dicts as a de facto standard. And we have the data classes backport, which was pip installable. And fun note, also they added math.tau as 2Py. And of course, much more. So you can go into the release note to read more about that. Python 3.7 was later released in June 27th of 2018. And some of the features we started to get in Python 3.6 were formalized at this point, while also bringing some significant performance improvements. So we got order dicts as an official standard. We got data classes built in as a PEP, and we got two-way formatting for datetimes, ISO formatting. And this is something I don't hear a lot of people talking about, and it's maybe a small feature, but for me this was really nice because prior to that I always had to rely either on third-party libraries or custom code just to be able to both decode and encode ISO formatted date string. We also got some significant speedups in the entire runtime. And of course, many more things, which you can read about in the release notes. So a new dawn, 2019 to present. So the year of 2019 came to a great start. I reincorporated my old business, Hultner Technologies AB. So I had this business back around 2010, and then around 2013 I had put it on hold for studies, and then I worked a couple of years in industry before going back to my own company again. But other than that, I also did a lot of other things. So one of the things I did was writing an article about the walrus operator, which we probably have heard about by now. This was one of the new features in Python 3.8, and I was playing around with the alpha at the time. It was quite controversial at the time, and with the first alpha version of 3.8 out, I just took the opportunity to write an article named Try Out the Walrus Operator in Python 3.8, where I took an objective and informative look on the feature from a technical standpoint without going into the opinions or debate around it. And this article got more popular than I had ever imagined. So yeah, I had never expected it to gain such wide popularity or at such a pace. So it was featured by the Medium curators in the programming category and was trending in several prominent tech communities. It was featured on Python sites, in newsletters, on the Python Bytes podcast, and our article still gets between first and the second highest ranked result if you Google for Walrus Operator. And a long time has passed, but around this time, I have passed way over 100,000 views of the article, and I'm actually planning to pick up my technical writing again sometime this year. I just haven't had much time with having my own company again running. Something else I did was talk about property-based testing at the FOSS North conference, as well as at PyCon Sweden later. So 2020 then. As we all remember, COVID hits and it's still here, but it did bring some good things as well. So we got the end of life of Python 2, hence this talk. And remote conferences like this one increased accessibility of conferences. And I've been able to talk at conferences every month. But I still do miss the social aspect of in-person conferences. I hope that maybe after this period has passed, we will have both in-person conferences and some online conferences as well. Would be nice to have both at least. And of course, Python 3.9 is out. It's been out now for a couple of months, and I've been using it, and I think it's very nice. Lots of other interesting things happened as well in the Python world. Some of the things I found particularly interesting was the Schema Thesis project, which I've been very involved with and been talking about in quite a few conferences last year, and also contributed a little bit to their code base. And I talk a lot with their creator, Dimitri, as well. And something else I find interesting is the Piston 2. And of course, less time commuting means that we can spend more time to experiment as well. So I want to talk a little bit more about Schema Thesis. I have a full talk on this, so you can find it on YouTube if you want to learn more, but I want to just very briefly go into what it is. So it's a better way to handle API testing. It uses OpenAPI to automatically generate tests. It's very easy to use. It's based on randomized property-based testing. For those of you who haven't heard about it, it's a way of letting the computer do the heavy work of finding test cases and letting you do what you are best on instead. So I have a EuroPython talk, which you can see on this link. And here's the GitHub repo repository and the docs for schema physics project as well. So basically, it lets you test more with less code and reach deeper into your code with the tests given. So if you haven't checked it out, I highly recommend you to give it a look and try it out. And if you use OpenAPI, it's actually able to work with GraphQL as well. This is being developed very actively. So I forgot to write this in the slide, but if you use GraphQL, you can try it out as well. But OpenAPI was the primary target. Something else about experimenting is that I, with my colleague Magnus Junghard, started a new project called Paper.io. So basically, we wanted to utilize all these new features, and we built the backend fully with Python 3.8 and later 3.9 now when that got released. We use async IO and fast API. We use async task workers. We have a fully type annotated code. We use MyPy everywhere. And we use automatically generated TypeScript API interfaces based on backend types and schemas. We use Pydantic for runtime type checking. And we, of course, use property-based testing and randomized testing. All this to be able to deliver better results faster. So basically, this was a great way for us as well to utilize all the latest and greatest features of Python as well. So then what is Paper.io? I'm not going to talk too much about it because that's not the point of this talk, but basically, very shortly, me and Magnus had struggled quite a bit with creating attractive PDF files that adhere to the standards, design guidelines, and similar for different companies. And doing this in a scripted manner dynamically was quite difficult. So we wanted to be able to utilize the full power of the web. So basically, we can use HTML, CSS, JavaScript, or maybe Django or Flask to create the HTML sites, and then we can convert them with our API to PDFs. And the whole idea is that the API is a turnkey service, but it can be run on-premise as well. And it can be used, for instance, to visualize complex data in reports, maybe create tickets, invites, receipts, invoices, packaging slips, return labels, flyers, pamphlets, manuals. That's some of the use cases we've been thinking about and that we've had before. And the closed beta list opened quite recently. So if you find it interesting, you can sign up at papero.io/beta to be put on the waitlist. And if you do so we will get back to you as soon as we have time to take in more beta testers. So let's go into Python 3.8 then. Python 3.8 was released in October 14th of 2019. And this was actually the first release with the steering console. So with the steering console, we got a lot of time put into getting that up and running. So maybe not a lot of big changes, but it's a big step for the future of Python. And it's good in the long term to have a more defined way to work with the governance of the language going forward. But some of the significant features we did get was the assignment expressions, the walrus operator. We got positional only arguments, and there was a lot of efforts to stabilize the entire project. So, and of course, you can read more in the release notes. And then let's go ahead to Python 3.9, which was just released in October. And some of the significant new things are stable annual release cadence. So from now going forward, the Python will be released on a stable schedule every year. We got the union operators in dictionaries, so we can now merge dictionaries using this new syntax where we basically have A union B instead of doing, for instance, a splat merge, which you could do before, but which also has some problems. We also got type hinting generics in the standard collections. This means that we can use list instead of typing .list with a big L, so we can use the standard list instead directly for our generics. And just the other day, Python 3 or MyPy 0.8 was released. So MyPy also supports this syntax now in type annotations. There's still some work on the runtime parts of that being done, but I think that also will be released soon. And Python got a new peg parser, which will allow the language to further evolve. And it's a new full new parser, so it doesn't do a lot right now, but it will enable some cool things in the future. And a lot of massive improvements in time zones as well. And of course, more in the release notes. So that was the basics of Python 3.9 then. So what does the future hold then? So in the near future, we have Python 3.10 coming out. Of course, nothing is set in stone yet with Python 3.10, but something that is being discussed a lot is the structural pattern matching, and there's a specification for that. This is basically a smarter pattern matching that can utilize the new peg parser. I think this is the first significant feature that actually needs the peg parser, and it allows you to be able to do pattern matching dispatch in a similar way as many functional languages, which is like Haskell or Elixir or similar does it. So that's one thing I'm really excited for, and it's going to be really interesting to follow that and see how that turns out. And as I've been mentioning before, MyPy is constantly evolving, but we also see a lot of new type checkers popping up. So basically, it feels like every big tech company right now is building their own type checker, and I think it's good to have some different options in this space. It helps in innovation, and it's easier to grow, and it's very interesting to see all the different takes and niches the different type checkers have. And as I mentioned previously, MyPy just released 0.8, and I think that was the last release which was holding back TypeShed, for instance, to use the new generic type annotations, so you don't have to import the generics from the typing module anymore. That's also something I find very interesting, because that's one of those gotchas a lot of people get when they start using type annotations, and I've been there myself as well. When you start doing it, and it's very easy to just use the standard dict, to use the standard list, and maybe you don't understand right away why it doesn't work, but now it will work, and I think that's a good step forward as well. And of course, the Python community it's growing, and it's always growing, and I'm always amazed about how fast it is growing. So it's an ever increasing pace, and I think it's very interesting to just see what's happening. And I love how inclusive the Python community is as well. It feels like most languages I've been in doesn't have the same sort of community we have, or are a bit behind. So I think that's one of the things I value most about Python. So I came for the language, but I would say that I've been staying here for this long because of the community. And it's really interesting to see new developers and developers from areas where we haven't seen them before, or different takes on things. I mean, I think it's very great for everyone in the long run to get as many perspectives as possible on the whole ecosystem. So I hope Python can be a good way of setting an example for how a programming community can work, and how it can be more inclusive, and that more languages will adopt similar ways of working. And further ahead then, so what will come next then? Will Python 4 come around? And when it does, will it be another transition like the one we got from Python 2 to Python 3? I suppose some people are worried about that. But I don't think anyone should be worried about that, because everyone has learned from the Python 2 to 3 transition. And this is discussed a lot. So I think there's a very little risk that there's going to be a significant change that's going to be backwards incompatible in the way that we saw with the Python 2 to 3 transition. And I mean, it's not even sure that we will have a Python 4. But eventually we probably will. But at that time, I think we will have a much smoother transition, and I don't think there will be a lot of difference then going from Python 3.9 to 3.10, or from 3.8 to 3.9. And that's, of course, also very important to think about, that we need to learn of our mistakes, because everyone makes mistakes all the time. And yes, Python 2 to 3 was a mistake. There was a lot of things that could have been done better. But we've seen the evolution of Python 3, and I think we learned from the mistakes of the Python 2.3 to 3 transition, and we haven't seen the same thing in the Python 3 releases, and that's something that's great to know. And I think that's also a sign that we have a healthy community, instead of just turning a blind eye to what has been, or what mistake has been done in the past. We actually try to embrace them and think about them, and think about how we should go forward to not make the same mistakes again. So with that said, I'm gonna conclude my talk for today, and I'm open for questions. So my last slide is gonna be something of a link fest, but basically here are some links to what I've been talking about today. So of course you can find all the slides, as I said before, on slides.com/Hultner. So that's great if you want to click these links or don't want to remember all of them. And you can ask any questions you may have now, and I will answer them. But if you don't want to ask them now, you can contact me via Twitter or via email, and I will answer later, or via the chat in Slack. And if you want to learn more, I'm also available for training, for workshops, and for freelance consulting. Just make sure that you contact me a bit ahead, because I have a quite tight schedule right now. And as I said before, the beta list for Papero is on papero.io/beta. A lot of my previous talks are available on YouTube, and I have linked a playlist I've created here. So in that playlist, I've gathered most of my talks for you already. And you can find more things I've done on github.com/Hultner as well. And you can find a lot of more information about this talk and some examples on github.com/Hultner Technologies/evolution of modern Python. So that was it for me.